In this module, we shall derive the standard and diametric forms of a circle. Look at the polygon shown. This polygon has 6 sides. On increasing the number of sides by 2, we get an octagon. As we keep increasing the number of sides of the polygon, the shape of the polygon keeps changing. As the number of sides approach infinity, the shape of the polygon approaches a shape which we know as a circle. Hence, a circle can be regarded as an infinite-sided polygon. A circle can also be visualized as a 2-dimensional slice of a 3-dimensional figure. For instance, the cross-section generated when a plane intersects a hollow sphere is a circle. Note that the intersection leads to a circle irrespective of the orientation of the plane. The intersection of a plane and cylinder also leads to a circular cross-section, given that the plane is perpendicular to the axis of the cylinder. A circle is also known as a conic section. It is obtained when a plane intersects the cone such that the plane is perpendicular to the axis of the cone. Now consider the circle shown. We can select a point C inside the circle such that the distance of this point is same from all the points lying on the circle. This fixed point is called the center of the circle, and the fixed distance is known as the radius of the circle. We can define the circle as a locus of a point which moves in a plane, such that its distance from a fixed point lying on that plane is always constant. Let the coordinates of the moving point be denoted by the variables x and y. Consider the coordinates of the center of the circle as h, k. Let us now find the equation of the circle in terms of the parameters identified. As point P moves along the circumference of the circle, the values of x and y change, but the distance PC remains constant and always takes a value of r. Distance PC can be expressed as shown using the distance formula. Squaring on both sides, we get a relation satisfied by any point lying on the circle. This equation is known as the standard form of the circle. Thus, the equation of a circle with its center at the point 3, 4 and radius as 5 units can be given in its standard form as shown. Also note that the equation of a circle whose center coincides with the origin is given by x square plus y square equal to r square. Consider the given equation. On comparing it with the standard equation of a circle, we can say that the given circle has its center at -2, 4 and has a radius of 6 units. Using these values, we can get the graph of the given circle as shown. We now look at the method of obtaining the equation of a circle when the endpoints of one of its diameter are given. Consider the circle shown. PQ is the diameter of the circle with its midpoint coinciding with the center of the circle. Also, CQ is the radius of the circle. We can find the center of the circle using the midpoint formula and then calculate CQ using the distance formula to get the radius. We can now substitute these values in the standard form to get the required equation. However, this method can be quite tedious at times. Let us see an alternate method. Consider a point A on the circle. As point A moves along the circumference of the circle, the values of x and y change. However, angle PAB always takes a value of 90 degrees as the angle in a semicircle is always a right angle. Since PA is perpendicular to QA, the product of their slopes should be equal to -1. On expressing the slopes in terms of the coordinates of the point and rearranging the terms, we get the equation of the circle. Now replace the coordinates of points P and Q with general values. This leads us to the equation of the circle as shown. This form is known as the diametric form. Summarize what we have learned in this module. We have seen that a circle is the locus of a point which moves in a plane, such that its distance from a fixed point lying on that plane is always constant. Further, we have derived the standard form and the diametric form of the equation of a circle.